Hi students, today let us learn physical properties of metals and non-metals and also some of the exception. So mercury is a liquid at room temperature. So we know that metals are all solids because they are having maximum rigidity. So that's why the state of matter is solid. But mercury is one exception. Its atomic number is 80, and when you look at its configuration, it is completely filled. 4f14, 5d10, 6s2. So, because of this completely filled orbitals, it gives stability for mercury. So, that is the reason why mercury is a liquid. And most often, we all know that metals also have very high melting point, but there are exceptions. That is gallium and cesium. Gallium symbol is Ga and cesium symbol is Cs, and they have very low melting point, means if you place them on your palm they will immediately melt because their melting point is 29.77 degrees celsius for gallium and 28.44 degrees celsius for cesium. So because they are, you can also know that the room temperatures around, or the our body temperature is 37, and hence gallium and cesium, the moment you keep it on your palm they will immediately melt. Now, the reason for this is that gallium and cesium, the distance, okay, see, when we talk about the structure of an atom, right, we all know it is having nucleus in the center, which is primarily made up of proton and neutron, and then there are electron. So, for gallium and cesium, it is said that the distance between nucleus and the outermost electron is extremely large. So, that is why, because of this nature, or because of this arrangement of electrons and neutrons, that is the distance between them being very very high, the melting point of gallium and cesium is very less. So these are some of the exceptions that you have to be knowing to write your exam. Now coming to physical properties of non-metals, so we all know non-metals physical properties is right opposite to that of metal. They are non-malleable, they're non-ductile, they're non-sonorous, and usually they are solids or gases in nature. But there is one exception, that is bromine, which is a liquid. Similarly, nonmetals are non-lustrous. We all know when we talk about carbon, coal, or we say talk about sulfur, it's yellow, amorphous solid. Similarly, when we talk about chlorine or bromine or any other halogens or even any other non-metal, even phosphorus, they are all non-luster. So mainly they are amorphous solids and they are non-luster. But there is one exception, that is iodine. See, iodine, when we look at the iodine crystal, it's very clear that its color is violet, but they are having this immense luster in them. Okay, they shine. So why is it that iodine, though being a non-metal, has shining appearance on its surface? So the answer is, so we should remember that all crystal or any compound has its own three-dimensional lattice structure. Now, similarly, when we talk about iodine, okay, so the on the screen you can see the three-dimensional lattice crystal of iodine. Here, the purple dots are nothing but two iodine atoms. So this is one iodine atom, and this is one iodine atom. So mainly iodine is diatomic, so that is why iodine is written as I2. Just like H2 or N2 or O2, iodine is also diatomic molecule and it is written as I2. Now in this position, students, in its three-dimensional crystal lattice, observe that all these purple dots are iodine. So you can see how the iodine has arranged itself in three-dimensional structure. Now when there is light, okay, incident on this crystal, okay, when light incident on this crystal, what happens is the moment it absorbs the energy, okay, we also know that there is a phenomenon called as reflection. Okay, now this light is gets reflected. So when it gets reflected in all directions, what happens is, for the viewer or for us, it looks like there is a lot of shiny appearance on the crystal of iodine. Okay, so mainly, so what we can say is, because iodine is has luster because of this three-dimensional structure, three-dimensional lattice structure, and these arrangement of the iodine at its positions in the three-dimensional structure is also visible on the screen. And whenever light falls on the crystal, okay, and because of the reflection, what happens is, so once light is absorbed, it also undergoes reflection. So that is, this reflection creates the luster nature or the appearance of luster on the surface of iodine. Okay, so these are some of the exceptions for metals and non-metals. The next video we will learn some more examples. Thank you very much. Please subscribe my channel.